Hello guys, welcome to project implementation on Nimbix Cloud. So we are going to log in. So we are in xilinscloud.jarvis.com. So let's log in. After we log in, we are going to run the Hello OpenCL application on Alveo FPGA card, which is located with Nimbix Cloud server. So first of all, we are going to build our project and simulate the project with software-based simulation, hardware-based simulation, which is called as emulation, software-based emulation and hardware emulation. Then we will create the executable file and run the executable file on FPGA platform. So guys, let's expand it, and we need to have Xilinx SDAccel development 2018.2 XDF. So guys, let's click on this SDAccel development. Let's click on desktop mode. Let's select the default machine type, which is the normal machine with 8 core CPU and 64 GB RAM. Let's click on submit. It will provide us the desktop layout for that CPU where we are going to develop our project, and finally we will compile the project and run the project. So it is still loading. So our cloud server with SDAccel or SDX install is already open. So this is Ubuntu version. So there is also tutorial PDF file which can be obtained from the desktop. So we are opening it, and we are going to just utilize the provided commands in this tutorial. So let's open the terminal, and we are just going to run the command. First of all, we are going to clone the Git. So for fast operation, we are just copying the command, and we are going to, so let's go to, actually we are trying to run this application which is inside this host Hello World OpenCL. So we have to go to host, and so we are going to, actually there is already the project. So first of all, we are going to emulate that project on software side. So this is the command. We can just utilize this command, and after software simulation compiles, runs, it will show some test pass result here. Then after, we are going to run the, we are actually building the software simulation now. We are going to run the software simulation in next after it builds. So we are building the project for U200 Alveo, Xilinx Alveo card, which is target board. So our simulation has been built. Now let's run the software simulation. So test has been passed. What we can do is we can compile the hardware simulation. We can build the hardware simulation. After it builds, we are going to again run the hardware simulation. There are two methods for running software or hardware simulation, actually the export method and make target all method. So let's see the Hello World OpenCL. Actually this OpenCL is the basic project flow of OpenCL example. So let's go to the source and let's see the source. Actually it have vector addition operation inside the OpenCL source file. So it actually add two vectors, array type of vectors, and gives the results. So this is the main OpenCL function which operate array AJ and array BJ computed for Cij, which is the vector addition right C of operation. So it must complete. So it is building the hardware emulation file. After it builds, we are going to run the hardware emulation source on the processing Ubuntu system. We are just processing the system on Ubuntu, and after it completes the building process, we are going to create the executable file and run that executable file on Alveo card. So we are just completing it. Hardware acceleration integration is developing. Let's again see the source, and we have two array. So array have some set of elements. First array has been read and the addition operation has been performed. So this is the OpenCL program. Actually OpenCL is much more optimized and easy to write, and the resource friendly, or it is optimized the resource utilization very well. So OpenCL is heavily preferred on bulk application like signal processing, like computing, DSP computing, and other high-end computing systems. It is still building. So you can also see the host.cpp. This host.cpp actually consists of all the host information which we are going to provide, some like environment information or a set of variables. So those are things which is needed to compile the OpenCL file. Another OpenCL file. So it has completed. So first of all, let's check the last command. We just make all. So now we need to run the target. So let's copy it and let's paste it. After it run the hardware emulation file, it will give us some test result here as the last software emulation give us. Actually the running process for this emulation is alternative process is explained here. So we can even do the export option. Now we are going to build the executable file, that is .exe file, which we are going to need on. So let's click on it. So it is again checking the license. After it builds, we are going to, actually the building process last time consumed a lot of time. So we have built last time the beard application. Beard application is just outside here. So inside the miscellaneous there is beard. Actually we just build this application in the Jarvis Nimbix CPU system, 8-core CPU and 64 GB RAM, and that takes around 4 hours. That's pretty like confusing. So it takes almost 4 hours for building that application. Hope this basic Hello World OpenCL application won't take much time. Let's hope. And basically this application, OpenCL Hello World application, is not much complex, so it will take less time than the previous one. The beard application is actually a little bit bulky, and it is also performing the addition operation, but it have different like algorithm. It seems simple, but the reading and writing process is a little bit different, which read simultaneously, read and write, and provide the operation function for computing. So it is just synthesizing. Actually it is also going to take like 15-20 minutes, and our CPU time can be seen from here. So we already around 12 minutes this time, and this is our overall jobs run. Before this current job, we have run another job of beard application, which takes 4 hours and around 30 minutes. So it takes 12 minutes. And we can also see some references about the cost it is charged for the compute we have utilized. And last time we used this development environment and Alveo runtime environment. This development environment actually developed the executable file along with software and hardware emulation, this Alveo FPGA, the card, FPGA card, Alveo card U200. We're going to utilize the exe file generated from this source into the Alveo card. Alveo card actually charges a little bit higher than the SDAccel development. So it charges $3 per hour and it charges $1.25 per hour. So we have this charge listed from the past work. So it is still synthesizing the project. So let's wait time. And just like to tell you about, if you want to send anything into this cloud or copy anything from this cloud, then you have to set up your FileZilla application for connecting this cloud server, and that part is actually explained on UG 1240 in the first section. So you can even go to that section. So it first explains about how to transfer data to and from Nimbix Cloud. So this is the process. You need to have FileZilla or other cloud client, host client. So you can just connect your host, and here are some steps which is needed for uploading or copying in the data from cloud server. So this is the UG 1240 from Nimbix. So we're also following this thing, and we already done something. So we are just making the application for executable file. After it makes, we are going to move the make file, which will be hello world _cl.exe, and it is running now. So it seems it is also going to take a bit time, and we can sort the data folder. So this is the repo which we clone from the GitHub. So that is, we clone the SDAccel example, and this is the example. We can see the getting started, and we can see we are currently inside the host, and previous application, beard application, is inside miscellaneous. So this is the beard which we already built, but this is not the machine where we build. Actually the beard application already lost after it builds, so we can do ourselves again. So we are just building Hello World OpenCL. So after it builds, we will see the .exe file here when the build completes. Actually the bitstream generation is still in line, so it will take a bit time. By then, let's also see if we have FileZilla or not. Actually we haven't installed FileZilla right now. I think other clients can also access. Our process is a little faster. Actually this application is not much complex, so we hope it will do a bit faster. So 12 out of 44 jobs has been completed. Actually there are lots of processes. After block level synthesis, there will be top level synthesis, then it will be implementation, bitstream generation, and executable file generation. These are the steps which this SDAccel application will going to follow on. After executable file generate, we are going to move the executable file to op directory, another directory, and will terminate the server, and we will then upload the executable file into the Alveo card. So guys, we are going to access our machine, this machine which we are currently performing from the FileZilla client. So FileZilla is actually the application where we can connect with our host, and we can transfer to and from data from the host. So the host ID is drop.jarvis.com, username is our username, password is actually the API key, port is 22. So let's see about the API key, and you can get your API key from the account and authentication. So this is the API key. Let's copy it and let's put on this, and let's do the quick connect. Let's do not save the password. After it connects, it will, okay, it is connecting. After it connects, it will show up the folder which we are currently accessing on. So let's go to dashboard, and our synthesis process is almost completing. Actually what we need is, let's go inside the examples, and we just need the tutorial so that we don't need to copy it. Let's copy it and let's put inside the data and examples. We can access it from our FileZilla, and we need to refresh it. So let's do refresh, and this tutorial, let's download it. We can download it. That's awesome. It is downloading, and after our program builds, executable file builds, so we have to check about where it provides the download file. So it must inside the downloads, documents. Let's check again manually the download steps. It must be in downloads, inside documents. This must be the tutorial. So this is it. Let's copy it, or we can even cut it. Let's copy it and let's put on here. So we get the tutorial, and we can also even download our past project. Actually we happen to have past project in this, but let's select getting started. Inside this there is miscellaneous and B8. So here we have some results. Actually this is the last results which we built on 11/27/2018, and today is 11/29. So the server is same, so we can just download it. Our file has been saved there, so we can just save the HTML, and we can even save the SDAccel. This is the profile summary, and we can again go to down documents and copy these sources into desktop. So we can even copy this exe file, beard executable. Let's do the downloads. Let's also see on the server side what is happening here. Actually we are just downloading these things. These things means we have already downloaded tutorial PDF. So almost block level synthesis is complete, and now we are just downloading. Inside the getting started there is our project miscellaneous. This is the past project which we already built on. We have downloaded the profile summary, CSV also Excel file, and this exe. So let's download this exe. Cancel. .exe must be, it is also here. So let's copy it and let's provide it on the desktop just for reference. Now we can see our block level synthesis is still running, and there is no other things which we need now. So if that need, we can just check it out. So this is the process for how to access your server from FileZilla client, and we can just close this. And if you want to know about what is the application which we are running currently, then we can go to host. Actually this question mark part is still syncing, so we need to sync for viewing the content of those, and we are running Hello World OpenCL. and there is no executable file and profile summary. So there is lots of things need to do. It is just running the top level synthesis now. So after top level synthesis completes, it will implement the design and generate the bitstream. Then we can run the command for executable file. Actually, executable file also generated automatically from the past command, so we don't need to worry about. So this is all about the FileZilla. You have to put the host. Actually, this information is provided in UG 1240. So you can also visit there. Username, password. Actually, password API key from your profile in Nimbix. Port is 22. So this is the server side, server files, and these are our files, local files. So we have just downloaded the server file into the local. Now we can disconnect it, else we can just quit it. It has just gone. So top level synthesis is still in progress. We can even see our compute time and the charge 5.94. Actually, what we have missed is if we have selected the power machine than the current one, then the process will take a little bit time. But we are just running the process SDAccel process on 8 core CPU and 64 GB RAM, which is taking much more time. Actually, SDAccel is resource intensive, so it is a little bit difficult to run this software, SDAccel software, in your PC while we run our SDAccel application on our PC. That application also take 2 hour plus time for basic addition subtraction application, so that take lots of time. I think the overall process is also going to take some 1.5 hours. So it is just completed the half hour. And another thing what we can do is we can just close this browser, but the process will still running on. So if we just terminate from here, then only process will stop. So we can even get notification of all the processing email, so we don't need to worry about what is happening there. For just precision approach, we are just looking at it, what are the process it is following on, and if any difficulties happen, we can just correct it at the moment. So we are just looking on it, else it is not necessary. Just look at it, just close it, and we can just open from it, and we can just, so we are also copying this P8 directory into our local one. So it is still downloading, so it is still performing. There are lots of steps remaining, so we are going to stop the process for now. So there are lots of steps remaining, and let's see how to implement the project, basic exe project, after we generate on Alveo card. Let's close it. Let's go to here. Let's shut down it. Force stop. Yes, it will stop. For now, we are just going to show up the demonstration what we are going to do after the .exe file is built. First of all, what we can do is, according to this guide, we can just follow this guide, and it consists of all the information which will be needed on. And after this command executes, that is the last command, executable file will be built. So if any file is not located in the data directory, that will be lost. So data is the user data. So data folder is actually the folder for us. So only the data for user will be saved for further purpose or future use. So let's see the process. We already have shut down it. Now we can go to, we already have shut down. Now we can go to SDAccel runtime, Alveo runtime. This is runtime, Alveo runtime. Then we can go to bash mode, and we can select the Alveo card. Actually, this is Alveo base machine. So we are going to follow on. What we need to do is we have to select the executable file inside examples. We are just going to show you the last examples inside the getting started. We have built last time the miscellaneous project and beard project. There must be .exe. So this is the .exe file. We can do submit. It is submitting, and we are just place other thing as default, and we will see the output in the screen. After it run on Alveo card, actually our charges has been increased and number of jobs is also increased. This is the basic process. And while so it is running, actually these icons are here because we have utilized this Alveo runtime also in the last step. So if you don't get that thing, then you can just go to compute and you can see this Alveo runtime. So if you click on this, we just go on from there. Actually these things are same, so you will get the dashboard and our test has been passed. So this is the beard application which we have compiled last time. So you can even download the results. It is still compiling, so after it completes we can just download from here. So this is the process, and you can also follow UG1240 if you get any confusion, or you can ask us. So guys, thanks for watching, and each time the charge will be increased according to your consumption of resources. So it has completed, so we can go to here and we can download this. Download into your own repository. So this is all. Now what we can do is, our dashboard has nothing in process. We have just terminated this, and we can just, if we just place anything running here, then it will always increase the charges because it charges on the basis of per hour. So we are just checking is anything left or not. So nothing is there. Now we can log out from service. So guys, thanks for watching. We'll meet you in another video of lab session.